Hello, Algebra 2 trig students. This is Mrs. Leopold, and we are on Unit 6, Parent and Piecewise Functions, with Lesson 4, more about piecewise functions. So here we're just jumping in right into example 1. I would say you could even pause and try this on your own. Nothing different about it, just having you find y values, right? So what is f of 1? Well, when x is 1, the y value is 1. So I would pause and try this on your own, even going through the piecewise equations to describe the function. So remember, if you're going to come up with a piecewise equation, you're going to have multiple parts. So let's go ahead and review those parts. One part is this purple part that I just drew, right? So we're going to have one part, and then we need to do the domain. Another part is this red part right here. So we're going to have that equation and its domain. And then this last part, I'll just keep blue, which is part of a line, I hope you're thinking. So we have the equation and then the domain restriction. So go ahead and pause and try this on your own. So is this what you got? Did you get 1 for f of 1, f of 1.5? When I go to the right 1.5, it's up here at 3. When I put in 2, I'm not here. That's an open circle, so I'm up here at 3 again. When I put in -2, oh, did we know it's exactly at 4? Yes, I did. How did I know that? Well, this purple part of the function, that's part of the parabola. So from negative infinity, it stops at 1. This is part of a parabola. The vertex is here at 0, 0. It went right 1, up 1, left 1, up 1, left 2, up 4. So it's just my basic x squared function. For the second one, it's a constant at 3. And so it's always going to be 3, the y value. If I start at 1 and end at 2, open circle on 1, therefore exclusive, closed circle on 2, therefore inclusive. And finally, this is a linear equation. If I were to continue this slope pattern, it would go through 0, 0. So my y equals mx plus b is just a plus 0, so I only have a positive 1 slope. It starts at 2 with an open circle, so it's exclusive of 2, and goes infinitely to positive infinity, which is also exclusive. So that's it. Now let's move on to example 2. I want you to give this a go as well. So it says, at Crazy Kate's boat rental, it costs $20 to rent a canoe, and you can use it for up to and including 4 hours for this price. So if you are in the canoe for 4 hours, you only have to pay 20 bucks. Additional time is charged at $5 per hour, even if you don't keep the canoe for that entire hour. So if you use it for 4 hours and 10 minutes, you're still going to pay the additional 5 bucks. So it says, sketch a graph to show the cost of renting a canoe from Crazy Kate for up to 8 hours, where X is the time in hours. So I was just going to say, what is our X and Y axis? Well, they just told us X is the time in hours. So what is my Y value going to be? Well, hopefully you're saying to yourself, that's just going to be how much money I'm paying. So I'm going to leave it at that. I want you to try to figure it out, and I want you to try to potentially write a piecewise function, or you can go ahead and do it along here with me. So hopefully what you remember is that this is called a step function, right? We have individual steps. So the first step is occurring for $20. If a canoe, we rented a canoe for up to 4 hours, then it's going to cost us $20. So if we don't rent the canoe at all, if we have it 0 time, then it's going to be no dollars at all. But otherwise, it's going to be $20 up until hour 4. After that, we have to pay an additional $5 per hour. So if we have it for 5 hours, then I have to pay an additional $5. So it's going to be $25 if I have it for 5 hours. If I have it for 6 hours, it's going to be $30, 7 hours, $35, 8 hours, $40. So again, what does it say? It says we're going to rent the canoe from Crazy Kate for up to 8 hours. And so I have to stop here at 8 because that's what it tells me to do. This is a step function. Notice as well that we have an open circle on the left-hand side, closed on the right, because if we use the canoe for 4 hours, we're only paying 20 bucks. If we use it for exactly 5 hours, we're going to pay 25, etc., etc. So it has to be exclusive on one level and inclusive on the other. So it looks like this. Now, if you're going to get the cost function, right, what is that going to look like? The piecewise equation for this. You could put C here, cost with respect to X. You could put an F of X. It doesn't matter too much, but usually we write C of X just to indicate that we're talking about money. So what do we have? Well, we have 1, 2, 3, 4, 5 different steps. So one where I'm going to have a constant of $20, $25, $30, $35, and $40. And now all I'm doing is identifying the domain. The domain is 0 to 4, and then it's 4 to 5, 5 to 6, 6 to 7, and finally 7 to 8. So that is what you should have had. All right, how about our next one? It says evaluate the following based on this equation right here. So we have this piecewise function, and we need to evaluate each of these based on this function. So we don't have a graph, we only gave it to you algebraically. So you're going to have to look at this and say, okay, h of 0, where would 0 be included? Well, 0 is inclusive here, so I'm going to plug 0 into this function. So I have the absolute value of 0 squared minus 4. That's the absolute value of negative 4, which is just 4. So h of 0 equals 4. Evaluate implies you're going to have a numerical value as your answer, right? So that's how we're going to do the next one. So now we have h of 1. So where is 1 included? Well, 1 is caught in between here, between 0 and 2. So I'm going to use this equation to solve for h of 1. So h of 1, I plug it in, I get 1/2 times 1 plus 4. So 1/2 times 1 plus 4 is 4.5. So my answer is 4.5. You can put 4.5. You can write 9/2. All of those answers are the same, and they are correct. Finally, if we're finding h of 2, well, 2 is inclusive in this third equation, so I'm going to use negative x plus 4. So I'm going to plug in 2 into this third piece, and so that's negative 2 plus 4, which is 2. So h of 2 would be 2. Moving on. It says use the graph of f of x to answer the following questions. So I would pause and try this on your own. Write the equation for the function, right? So you're just going to do the different pieces. So go ahead and pause and try this by yourself. Is this what you got? You should have gotten f of negative 9 is negative 7. F of 0 is negative 3. So f of negative 0.11111. Well, that's really, really close to here. So that would be negative 7. And 0.0011 is just to the right of 0, so that would be negative 3. What is the range? The range is not an interval of numerical values. The range is just simply negative 7, negative 3, or negative 6. Those are the only y values involved here. And then this would be your piecewise function, right? Because we have 3 different constants, we just have those 3 numbers here. And then where are they making those horizontal lines? Make sure you're checking your inclusivity and your exclusivity. Where are there open circles versus closed circles to make sure you have your domain correct, as well as these values here correct. Okay, moving on to number 5. It says write an equation for the following piecewise function. So again, if you are a color person or you're visual, I would be highlighting each of these sections and just making the different pieces in your piecewise function. So I'm going to have, oops, that's kind of a funny thing right there. I'm going to have 4 different pieces. How do I know it's going to be 4? Well, it's a little tricky. I'm trying to find where I'm going to write this for space. Okay, so 4 different pieces. One is right here. This is part of a line, right? So that's going to be one segment. Okay, I ran out of space there for my domain. Then I have this segment here, this part here, which to me looks like a cubic function, then with my domain. And then don't forget about this one singular point. So I just need to put that point in there. And then finally, I have this portion here, which looks to me like a parabola that is upside down. So the first one, you could do a linear function. You could also do an absolute value, actually. So this one right here could be a linear function or an absolute value. I would accept both. But you wouldn't really know it's an absolute value unless it had that hook on it, so I'd probably go linear. Then I have my function here, which is cubic. And finally, I have my function here, which is parabola. So go ahead and try this on your own, pause, and see how you do. All right, to look at my 4 different pieces. The first one I made linear, but to be honest, it would probably be easier for you to just make an absolute value, a piece of an absolute value, because all I had to do was say, this is my vertex at 1, 5. That's my vertex, right? So I just had to shift right 1, up 5, and then just count the slope, down 3, left 4. So it's a negative slope, so it might have been easier than what I did. So this could have been this graph of the linear with a domain restriction of -7 exclusive to 1 inclusive, or in this section instead, I could have put -3/4 times the absolute value of x minus 1 plus 5. So either of those worked. So that's why I have this or the word or there, because either equation would actually work. The second one was a cubic, but a cubic traditionally goes up like this. And so if it flips the other direction, then we have to have a reflection involved in there. So here I'm going down, so I had to have a center, right? So my center was 2, 2, and I had to reflect it. It's a cubic, so I put that here with the negative in front, and then it's exclusive, exclusive, so I have -1 to 1. Don't forget this point down here. This point is at 3, -2, so it has a y value of -2, and when x is equal to 3. And then finally, I have this portion here, which is a parabola. It's an upside down parabola, so we're going to have that negative in front. It also goes left 1, down 2, right 1, down 2, so it's been stretched twice as far. It had this vertex, so I put it all together for this piece of the graph of the function, and then that is my domain restriction there. So there you have it. If you have questions, make sure you touch base with your teacher. All right, next example, try it again. Pause and try this on your own. We can talk through it initially. Here, look at this. This is a V. I wouldn't do 2 different equations of lines. I would make this an absolute value function right there, right? So I would say this is an absolute value function in red. So I'm going to have my red portion and my red domain. Then I have this portion of the graph, which hopefully you say to yourself, oh, that's a parabola or quadratic. So I'm going to have a parabola and its domain restriction. And then this last piece is a what? It looks like a cubic, but it's not. It's a cube root, right? It's on its side, so it's a cube root. So that's my last portion and its domain restriction. So f of x is going to equal, and then I have my 3 pieces right here. So go ahead and pause and try this on your own, and then compare with my answer when you're done. All right, have a look. Did you get these 3 different parts or pieces of this function with their proper domain restrictions? So we said right here, this is an absolute value. This is an absolute value with the vertex at -4, -2. So that's all I need is to transform left 4 down 2, and then I need to count my rise, which is 5, to the right 2, so my slope was 5/2. And so this was the equation of the red portion, and it went from -8 to 2. Now -8 is an open circle, 2 is a closed circle, so I either have to include it here, oh sorry, that should be a -2. I either have to include it on the red portion graph, the absolute value, or I have to include it on the blue graph. Either one, I have to have inclusive one place and exclusive at the other because they join there. They can't be included in both or it wouldn't be a function anymore. You'd have overlapping point. This second portion was a parabola or quadratic, the quadratic with the vertex at -1, 6. And then we went left 1 down 3, right 1 down 3. So it has a stretch of 3 for the vertical dilation, and you have a negative sign because it's opening downward. I put in my vertex, left 1 up 6. So this is the function for the blue portion, and this is my domain, exclusive 2 because I included it up here, and then exclusive on the right-hand side because it's an open circle. And finally, this purple part is a cube root, a cube root right here. And so where is my center? My center is at 1, 3. And then notice it's supposed to go right 1 up 1, right 8 up 2, but it goes right 1 up twice as far. And so it's being stretched even higher. And this is not exact here, but you can have a look. Oh yeah, it is, sorry. It's being stretched up twice as far, so that's why I have a 2. Then I have my cube root of moving to the right 1, so -1, and then up 3. And then it's inclusive of the 0 because I have a closed circle and an open circle over here, so it's exclusive of the 9. That's it. Again, if you have questions, make sure you ask your teacher or seek someone else, a friend or a parent, to get your questions answered. All right, next question. This time we're giving you the different pieces. So 1, 2, 3, 4 different pieces to this piecewise function. You have to graph it over here. And then once you graph it, you can look at the domain and the range. Now the domain should be easy. You can already decide what your domain is based on this right here. So you could go ahead and fill that out. Your range, on the other hand, you're probably going to want to look at once you graph the picture. So again, I encourage you to pause. I'm going to do each different piece. So I'll do this part in red. That's an absolute value. Then I'll do my cubic in blue, this point in green, and my linear in purple. So go ahead and try it yourself. See how you do. Compare it with mine as soon as you're done. All right, check out your graph. Does your graph look like mine? So we had to do an absolute value here. First, so I had to do my vertex. My vertex is going to be -5, so I went to the left 5 and up 1. And then I have a slope of 5/2, so I'm going to go up 5, right 2. Well, that is where I am ending at this 3 right here. You might want to do this like dotted lines for yourself so you know this is where that absolute value graph is going to end. And it's going to go from -infinity all the way until you get to -3. So remember, you reflect it over this vertical line that goes to the vertex. So this is what your first part looks like, from -infinity to -3. There you have it. Next, for my blue portion of the graph, this is a cubic function. So my center is at -1, 0. So this is my center. Then I usually go right 1, down 1, left 1. I usually go right 1, up 1, left 1, down 1, but because of this negative in front, I'm going to flip it. So I go right 1, down 1, but it's half a stretch of vertical dilation of 1/2, so I'm only going to go half that distance. Usually I would go left and right 2, up 8, but I only go half that distance. And because it's exclusive and exclusive, I'm going to have an open circle here and an open circle here. And of course it ends at 1. Well, that is great because that's where those pieces of that function ends. And we will often do that. We're not going to end like midway where you don't know where it is. We're going to end at points that should be identifiable. Like it's specifically at 1, -4, there's an open circle. Then we have a closed point here. The y value is going to be 3 when the x value is 1. So at 1, we're going to have a y value of 3. So that's my green point. And then I have this equation of a line, which doesn't start until 1. So you could plug in the number 1, see that you're going to be up here at 5. And then it's a -1 slope. So I continue down and to the right. So I didn't fill in my domain and range. I thought I'd do that with you. If you look at your domain, this arrow goes out infinitely. Here at -3, it is defined. At 1, it's defined, and then it goes down to the right infinitely. So hopefully you had -infinity to infinity or all real numbers for your domain. And again, because this arrow goes up infinitely and this arrow goes down infinitely, you can also see that your range is from -infinity to infinity. All right, another one. Our last two are the same. You're going to graph the different pieces, then you're going to identify the domain and range. So I would try those on your own. There isn't anything too fancy about them. I'll do them as well and just talk you through them. Although I think you can go ahead and do them on your own. And if you just want to look at the answer key, the PDF, that's fine. Or you can listen to the video if you need to. Good luck. All right, so what do we have? We have this linear portion here, right? We would go up 1 and then do a slope of -2/1. So it has to go up 2 to the left 1, but because we're starting at -1, my line has to finally first start here and go continuously to the left. This blue portion is a cubic, so my center's at 0, 0. I would usually go right 1, up 1, left 1, down 1, but because of this vertical dilation, I have to stretch it up twice as high. It's exclusive of our 1 and -1, so I should have an open circle and open circle. The reason that's closed now is because for this next graph, the square root graph, was inclusive, so I have a closed circle on top. And then, of course, I move my vertex to the right 1, up 2, and then I usually go right 1, up 1, right 4, up 2, and then right 9, up 3. It fit on the graph, so I go ahead and went ahead and put that last point on there, and this is what we have. And then my domain and range is here. Domain infinitely to the left, infinitely to the right, so it's all real numbers. Range, there isn't anything down here, so it only goes down to -2. Open circle, so exclusive, and then it goes up infinitely, so it's to infinity. Again, try this last one on your own. Pause, go through each part, and then check it with me. All right, last one. We have a linear portion right here. So what do we have? This means I'm going to move left 5. So I move left 5 of a slope of -3/2. So there we have it. Then I have this portion of my graph, which is a square root, except the square root, you have to factor out that negative. So this actually means I have to move left 1 unit from my vertex. And then because of this negative underneath the square root symbol, that means I have to do a horizontal reflection. So I'm going to reflect. It's going to open now to the left instead of the right. So I go left 1, up 1, and then left 4, up 2, except it's an open circle because I'm exclusive here, inclusive here. Then I have this cube root. So my cube root center is at 0, 0, but I go up 5. I have a negative, a horizontal reflection again. So instead of going up this direction, it's going to go like this. And so from my center, I'm going to go up 1, left 1, open circle because it's exclusive. Then I go down 1, right 1, or right 8, down 2. So this is a cubic function right here. And then you can see arrows, arrows, up forever. This is going to go down forever and ever. And so my domain and range are both all real numbers. Again, if you have questions, make sure you check in with your math teacher. I hope you're doing okay this unit. See ya.